In this video, we'll look at question 22 and 25 because it's easier to cut them and paste them that way. During a season, a team called the Random Variables played 32 matches. 20 of them were in fine weather, and they won 16, and 12 were in rainy weather. So we'll do the totals first. 20 were in fine weather, and the other 12 were in rainy weather, fine and rainy. And of this 20, they won 16 of them. They obviously lost 4 of them, so won and lost. On a rainy day, their success rate was they won 4, and obviously they lost the other 8. Now, what are the probabilities here? They won 16 over 20, which is equal to 3/4. No, it's equal to 4/5. They lost 4 over 20, which is 1/5. They won 4 over 12 of these, which is 1/3, 4 over 12. And they lost 8 over 12, which is obviously 2/3. So here's the probabilities. What are we asked? What is the relative frequency of the random variables in fine weather? So that's the probabilities. Question 1, the relative frequency of random variables winning in fine weather. What do we have that done here? That's question 1 to 4 over 5. The relative frequency of random variables winning in rainy weather, we have that one as well. That's 1 over 3. And then part C says they're playing in the cup final next Sunday. The weather forecasts say that the probability of fine weather is 3 over 4. So we can add 3 over 4 up here to the fine weather part. So winning and losing, it's going to be 12 over 20. And this one's going to be 3 over 20. So it must be 1 over 4 for not fine weather. You can see I've just gone over it there, 1 over 4. So the probability of winning, and it's not fine, that's 1 over 12. And this one's going to be 2 over 12 without simplifying them. So what do they ask us? Using the relative frequencies as probabilities. The probability that they will win. What are the 2 wins? We have this one here. (12 over 20 plus 1 over 12). They both went to 60. So that's going to be 36 over 60 plus 5 over 60. 41 over 60 is the probability that they'll win. Okay, over to number 25. Ben shoots 4 arrows at a target. Very similar to a Leaving Cert question that was asked. The probability that he hits the target in general is 0.3. So let's write this down as we go. The probability he hits, we'll call it probability H, is equal to 0.3. So the probability that he misses, hard target to hit, is 0.7. This increases to 0.4 if he has hit the target on his previous shot. So the probability of a hit, if successful on previous, is 0.4. So the opposite of that is 0.6. So that obviously if he misses, if the probability that he misses if successful on previous. Then we have it decreases to 0.25 if he's missed. So the probability that he hits if missed with previous, that's going to be 0.25. So the probability that he misses if missed with previous must be 0.75. We will call H a hit and M a miss. Answer these to correct the 3 significant figures. Okay, H is the first one. The probability of H, 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 H. So probability that he hits on the first one is 0.3, independent of anything else happening. So he has hit. The probability that he hits, if successful on the previous, is 0.4. So we're going to multiply by 0.43 times here. And that's 64 trees, 192. 0.0192, 4 decimals. Probability of a miss. So this is the 0.7 to begin with. Times, so he misses having missed with the previous one. He misses having missed with the previous one. 0.75 by 0.75 by 0.75. So that's going to give, just use a calculator here. I've written down as a fraction. That's 0.295. 0.295. The probability of miss, hit, miss, miss. Okay, you'll only be successful with the second MHMM. So the probability will come up the top actually, MHMM. So the first miss is 0.7. So he hits having missed previously. He hits having missed with previous, it's 0.25. So then he misses having hit previously. So he misses having hit previously, is this 0.6. And then he misses having missed previously, it's back down to this 0.75. And that's going to give us an answer of 0.0788 for that one. And then we're asked for, he will hit with just one arrow. Probability hit with one arrow. So we have 4 options for this one. We have this guy here, that's miss with the second. So we need the probability of miss with the first. Sorry, hits with the first, miss, miss, miss. That's in the first position. The H, we have the position for position 2 from up above. 0.0788, that's when H is second. When H is third, we have the probability of MM, HM. And when H is fourth, we have the probability of MMH. So now we need to look at these. Hits first, it's my 0.3. Misses, having hit previously. Misses, having hit previously, is the 0.6. Misses, having missed previously, is the 0.75. So we've 2 of them. See now 0.7, 0.3 obviously at the beginning. So 0.3 by 0.6 by 0.75 by 0.75. I need a bit more room. It's 0.10125. 10125. Okay, we have the second one, HM. So the miss at the beginning is the 0.7. Miss, having missed previously, 0.75. Then we're looking for hit, having missed previously. Hit, having missed previously. So hits, probability of hitting, having missed previously, 0.25. And then missed, having hit previously. Missed, having hit previously, back down to this 0.6. And these multiplied together, it's 0.07875. 0.07875. And finally we have miss, 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 hit. So that's my 0.7 at the beginning. Again, 0.75 is the same as the one above. and then we have another 0.75, and then we hit, having missed previously, is the same, will be the same as this here, 0.25. So this is going to give us 0.098, 0.098, 4375, and I rounded this one off earlier to 788. I'll go 7. Well, I'll leave it. Does it 7875? I'll change it to 7875. Just have the 5s giving us a 1 here. So we add these together. This is 875. Add the 2 of the middle ones, and then the other 2. It's going to give us a total of 0.3571. And I think it said 3 significant figures, is it? No, we just leave it at 3571 then. 0.3571. Well, it would actually be 72.